Okay. On Friday, we basically talked about the different angles or all the different angle things about triangles that we've got. So today, we're going to talk about, now instead of one triangle, we're going to talk about two or more triangles or any shape. We're going to talk about what makes two shapes congruent. Okay? Well, in order for two shapes to be congruent, there has to be some kind of movement that you can make to move one object on top of another. We call that a transformation. A transformation is an action that can be performed on a geometric object without changing its size or shape. In other words, it's going to be the exact same size and the exact same shape. It's not going to change from a triangle to a rectangle, and it's going to be the same size. There are three types of transformations that you can use to transform a shape onto itself. The first is a rotation. Like, for instance, if my calculator is my shape, okay? A rotation, if I rotate it like that, it's still the same size and it's still a rectangle, it's just moved to a different position. So a rotation is a transformation that would show that one shape is congruent to another. Then we've got a translation, Translation. A translation slides the shape from one shape to another. So if here's my triangle, a translation just slides it. It doesn't change size and it doesn't change shape. It just moves the shape. And then we've got a reflection. Reflection. A reflection. What a reflection does is it flips the shape. Like if my calculator is reflected over a line and it turns it upside down. It's still the same shape, it's still the same size, but it's just been flipped over. Okay? So those are your three transformations that show congruence. Now, we will be able to rotate a shape, translate a shape, or reflect a shape, and be able to move that shape to where it fits exactly on top of another shape. Well, if you can do that, if you can rotate, translate, and reflect a shape to where it matches up exactly onto another shape, then we can say that those two shapes are congruent. C-O-N-G-R-U-E-N-T. Just like we can have segments that are congruent or angles that are congruent, shapes are congruent if they have the exact same size and the exact same shape. Their corresponding sides would be congruent and their corresponding angles are also congruent. So when we contort it to where one lays on top of the other, the sides that correspond will be congruent and the angles that correspond will be congruent. Okay? So, here's the symbol for congruence. It's an equal sign with a little tilde above it. That means is congruent to. It's just like an equal sign. Equals is for numbers only, though. This is for shapes. All right? Congruent triangles, C-O-N-G-R-U-E-N-T, congruent triangles are triangles with all corresponding sides of equal length and all corresponding angles equal measure. Congruent triangles have the exact same size and shape. So basically what I can do is I can move the one triangle that on top of the other one and match up exact perfect. Okay? Well, if they're congruent, then we can write what's called a congruence statement. Congruence, C-O-N-G-R-U-E-N-C-E statement. S-T-A-T-E-M-E-N-T. A congruence statement. And all a congruence statement says is it tells which sides or angles of two triangles are congruent. This right here is going to be the most important part of the day because you can tell what sides are congruent to what sides and what angles are congruent to what angles with the congruent statement. and it's all about the letters and what order they're in. So here's our first type of example. If I were to take this triangle on the left and I were to move it, it should, if I were to rotate it, translate it, or reflect it, it should lay on top of this second triangle exact perfectly. Okay? So what I would say is, what would angle M have to go over? Which one of those letters would angle M have to lay over if I were to just translate it? R. So I'm going to put an arc around R. Where would N go? I'll put two arcs around N. Where would N go if I were to slide it over? Q. And then O would go to P. Okay? So my triangle congruence statement. So first off, we're going to name it a triangle. Triangle MNO. Doesn't matter as long as it's any three letters. All right, in any order. Is congruent to. Now, here's where it makes a difference. This is important. If we call this triangle MNO, the corresponding vertices have to line up in order. So, M is the one arc that we put. R would have to be the first letter of the second triangle. N is the second letter we put down. Q has to be in its place. N and Q both have to be in the second place. O is the third letter we put down, so P is the third letter we put down in this triangle. And then all of its vertices are lined up. M is in the same spot with R. N is in the same spot with Q. O is in the same spot with P. Now that's important because when we go to name which sides are congruent and which angles are congruent, all we have to do is look at our letters. For instance, side MN right here is between the one arc that I wrote and the two arcs. What side is between the one arc and the two arc on this triangle? RQ. But look here, MN is the first two letters. The first two letters of this triangle is RQ. So we can just look at the letters and we can say that segment MN or side MN is congruent to side RQ. And it doesn't matter about the order. It can be QR or RQ or NM or MN as long as these two letters are congruent to these two letters in any form. Okay? All right. So then we go from N to O. N to O, well look here, N and O is the second and third letter of that triangle. What does it correspond to over here? N and O would go to second and third letter over here. QP. So we'll put that segment NO or ON, it does not matter, is congruent to segment QP or PQ, as long as the letters are there. Okay? And then finally, MO or OM. That's the first and the last letter, isn't it? M and O are the first and the last letter, so I would say MO is congruent to, what's the first and last letter of this second triangle? What's the first and last letter of that second triangle? R and P, or P and R. I'll put R and P. Now, if you want to put PR, that's fine. Does not matter. As long as the letters are there, you're in good shape. Okay? So that's how you determine the sides, what's equal to the sides. Okay? The angles are even easier. Angle M right there, it shared a vertex with R, so M and R are the first letters. We'll say that angle M is congruent to angle R. M is congruent to R. Then the second letter, N, has to be congruent to the second letter of this triangle, Q. Angle N is congruent to angle Q. And then finally, the last letter O of the first triangle has to be congruent to the last letter P of the second triangle. So we'll say that angle O is congruent to angle P. Okay? So that's how you're going to determine what sides go with what sides and what angles go with what angles, just by looking at the lettering of your congruence statement. Okay? The congruence statement will tell you everything you need to know. Okay? Is that cool? Alright. So, if two triangles are congruent, then the corresponding parts of the congruent triangles are congruent as well. Sometimes we might have to say that. Corresponding parts of congruent triangles are congruent. Well, that's a mouthful to say, isn't it? We don't want to keep having to say corresponding parts of congruent triangles are congruent. So what we do is we put an initial it. Instead of corresponding parts of congruent triangles are congruent, we just write CP, CT, C. And that's from the first letters of the big words. Corresponding parts of congruent triangles are congruent. Just using the first initials of that statement. And it basically says if two triangles are congruent, then their corresponding parts are congruent. Okay? Any questions? Alright. Next up, we've got some properties of congruence. Just like we've got properties of numbers, we've got properties of congruence. And some of them are going to be pretty self-explanatory. That, they just got weird names, or we have to name them. The first property is if a triangle is congruent to itself, or if a segment is congruent to itself. Like, for instance, segment QP is congruent to segment QP. Well, if I have something that's congruent to itself, we call that the reflexive property. The reflexive property. The reflexive property is actually a pretty important property because we use it quite a bit when we do proofs in geometry, okay? Or when we're determining if two triangles are congruent, all right? The reflexive property, I'll show you a good example of when we use the reflexive property, okay? If I have two triangles that share a common side, like so, we'll call this triangle ABC and this triangle QBC. Well, notice that those two triangles have a shared side, don't they? So when we're doing triangle congruences, we would say that CB is congruent to itself by the reflexive property. So the reflexive property is actually pretty important. We just have a name for something as easy as something is congruent or equal to itself, okay? So that's the reflexive property. Well, the next thing, if we go to, how we say stuff, 2 plus 2 is equal to 4, right? Everybody agrees with me there. There's no debate about that. But we can also say that 4 is equal to 2 plus 2, right? Doesn't matter how we say it, 2 plus 2 is 4, or 4 is equal to 2 plus 2. Well, that's a specific property that we call the symmetric property. SYMMETRIC, and then property. The symmetric property is just a way you can reverse the statement. It doesn't have to be triangle ABC is congruent to DEF. You can say that DEF is congruent to ABC. That's the symmetric property. That's the same thing as me saying 2 plus 2 equals 4 is the same statement as me saying 4 is equal to 2 plus 2. They're equivalent statements. They're just written a different way. All right? And finally, the last property we need to discuss is the transitive property. TRANSITIVE. Transitive property. The transitive property is just a chain of congruent statements where the first triangle is congruent to the last triangle. Okay? It's like taking a bus. Okay? Or taking an airplane. A transit. Like saying, here's transit 1. Here I get on bus ABC, and it takes me to bus DEF. Okay? Then DEF takes me to XYZ. Well, instead of going 1 to 2 and then 2 to 3, it's easier just to go 1 to 3. Okay? So this right here goes 1 to 3. That's the transitive property. Okay? If bus 1 takes you to bus 2, and then bus 2 takes you to bus 3, well, why not just have a bus that takes you from 1 straight to 3? Be a lot easier, wouldn't it? Well, that's what we call the transitive property. Okay? Anybody have any questions? Okay. So, if you got this written down, go ahead and flip it over to the next side. Alright, now we're just going to go by appearance. What triangles appear to look exactly the same, or which two triangles appear to be congruent? Let's start with A here. Does A look like it has something that, this looks equilateral? Is there another triangle here that A looks to be the same size as? I don't see anything that looks equal. That doesn't look equilateral. That one doesn't look, it kind of looks equilateral, but this side right here is a lot shorter than the other two. So I don't think A has a partner, does he? What about B? It looks like an isosceles triangle with two long sides and one short side. Well, E kind of looks like it, but this one has all acute angles. This one has an obtuse angle. So B, do you see anything that looks like B? You see anything that looks like B down here? What about C? Look here. C's got a short side, and it looks like that side and that side might be equal. Does C and D look? No, D looks kind of like a right triangle, doesn't it? So C and D don't look together. C doesn't have any obtuse angles in it, but E does, so we can't say C and E. And plus, E's a lot longer than C. But C does look like which one, if I were to rotate it, C would be congruent to what? F. So we could say C, triangle C, is congruent to triangle F. These two right here look almost identical if I rotated that one down to here. And then D and F don't have any pairs. Okay? What do you think? Think you can look at that and determine which is bigger or which is the same size? Let me ask it a little bit differently now. Now, we're going to find out which one does not appear to have a congruent partner. Okay? Which one of these does not appear to have a congruent partner? So we're going to rotate, reflect, or translate these and see which ones could go exactly on top of another one. So look at A right here. Is there any of these triangles that look like, well, it's got a short side and then maybe that's congruent to that? What does A look like it might be congruent to? C, if I take this one and rotate it to there, it looks like it would fit, and it does. So we would say triangle A is congruent to triangle C. So we've eliminated A and C because they have a pair that looks like each other. What about B? Well, let's look at some attributes of B. B has an obtuse angle and then a long side right there. Is there any triangle that looks like it might be congruent to B? G, because G's got an obtuse angle. So basically, maybe if I reflected that and then moved it down here and then twisted it a little bit, triangle B would be congruent to triangle G. So we'll mark B and G out, which brings us to D, E, and F. Which one of those does not look like the other? Well, D and F both have obtuse angles in it. Does E have an obtuse angle in it? No. D and F would be congruent to each other. So E is the only one that doesn't have a congruence to it. E, triangle E, is not congruent to any of the others. All right? Any questions on those? So be able to look at them and see which ones don't look like the others. All right. Any questions? All right. Coming on down here. Now we're going to make a congruent statement. We're going to make a congruent statement. All right? So we've got triangle A, B, C. A to B to C. Now, what does it look like I would have to do to this triangle to where it would line up exactly with everything on this triangle? Would it be a rotation, a reflection, or a translation? A reflection. If I reflected it over this imaginary line right there, it would line up one for one. Well, here's the deal. A is our first letter. What would A move on top of if I reflected it over that line? X. So I would put triangle ABC is congruent to triangle X. What would B flip over to? Y would go second. And then what would C go over to? Z. Thus we've made a congruent statement. And that's how you do it. The corresponding parts, the corresponding side, AB, would correspond to XY or YX. BC would correspond to ZY or YZ. And AC would correspond to XZ or ZX if I flipped it over that imaginary line. All right? The letters tell you everything. The letters tell you everything. And the angles, same thing. X and A. Angle X and angle A would be congruent to each other. Angle B and angle Y would be congruent to each other. Angle C and angle Z would be congruent to each other. So that's why a congruent statement is important, especially on problems like this. Alright, look here. Triangle ABC is congruent to triangle XYZ. So if I'm using a congruent statement, triangle ABC is congruent to triangle XYZ. Alright. It says that XY is equal to 3 units, AC is equal to 10 units, and BC is equal to 11 units. Then what is YZ equal to? What number could I stick in for YZ? Well, let's see here. Y and Z is the second and third letter of the second triangle. What two letters correspond with Y and Z over in the first triangle? Second and third letter. YZ corresponds to what two letters over here in the first triangle? B and C, right? Well, BC is 11, so YZ is equal to BC, which is 11. Okay? Does that make sense? Am I going too fast? All right. Last thing. Triangle MNO is congruent to triangle RST. So if I'm looking at the congruent statement, MNO is congruent to RST. And the letters are going to tell us everything. RT is 24. What else would be 24 besides RT if I'm using the same letters? RT is 24. What else is 24? MO is also 24. MN is 30. Well, if MN is 30, what else is 30 from the second triangle? RS. Okay? RS is 26, and already I see a typo. RS is 26. It has to be the same thing as MN, doesn't it? So technically this is wrong, but if I'm going by the letters, MO would be the first and the last letter. It would be the same thing as RT, which is 24. Okay? That's it. All right. Good day today, guys.